What's up, guys? Vylocity back with another Unreal Engine 5 material tutorial from Pitchfork Academy. And in this video, I'm going to show you how to create a realistic glass material that uses the thin translucent shading method. It's a little bit different from my previous glass material video. It's using the updated method for thin transparency, which just is a little bit more of a realistic way to handle reflections and the coloring of the glass as well as the opacity. I'll also be showing how to add some nice smudges or dirt on the surface, as well as a normal map texture or pattern to sort of add some character to your glass so it's not just a flat surface if you want. Obviously, it's an option. You could leave it flat if you like. And I'll also be showing at the end how to enable hardware ray tracing and reflections to help bring the Lumen reflection quality up a little bit higher if you have an NVIDIA card. If you don't have an NVIDIA card, don't worry, there's a couple of tips in there at the end as well for you that will still improve the quality of the reflections in general. Just before we hop into the tutorial, if you guys like what we do here at Pitchfork Academy, the number one way to support us is to check out our new game, Skyblocker, which we just released on Steam. It's a fun and competitive 3D puzzle game where you battle the elements and gravity. It's complete with awesome unlockable block skins, multiple levels, and a global online leaderboard to compete with your friends and others around the world. I hope you enjoy it as much as we enjoyed making it. Now let's get into the tutorial. Alright guys, here we are in Unreal Engine 5.6, and before we start making the material, I really quickly want to grab a texture from Fab. So I'll go to the Window tab up here and then click on Fab, and then this will bring us to the Fab Marketplace, and then I just want to search for Quixel Print. This should bring up some fingerprint textures that we can use in our glass. On the left, I'll sort it by materials and textures, and then at the top, I'll click Price and then select Free. This will make sure it's only the free options. I already have this first one in my project for testing, so I'll just click this second one. They're all pretty similar, as you can see. And the medium quality should be fine. This is just a 2K texture. For smudges on your glass, you could even probably go as low as 1K, which is the low quality. But depending on how large you're going to scale the smudges, you might have to go up in quality so it doesn't get too blurry. I'll just click Add and then accept the agreement. And it should download the material and make a new folder in your content browser if you didn't already have a Fab folder. So if I go to my content browser here, you can see we have this Fab folder. So I double click that, double click Megascans, surfaces, and then here's all of our textures. As you see, I already have a couple in here, but this is the new one right here. So if I go into here and then textures, we should just have the single texture. And the reason that it looks bluish like this is because this is a mask texture, so it has different information in the different channels. So if I deselect the blue and green, we only have this mask right here. I believe this is the roughness map, and then the second one here, I'm not sure. This also could be used as a roughness map, but nonetheless, we will use probably the R channel for our mask to blend in some smudges and dirt. I'll go ahead and exit out of that and click Save All, just to make sure if we crash that the textures are still there. Quickly, I'm going to go back to Fab and just search for Quixel pattern, maybe something like that, just to see if we can find a texture that has some detail to it that we can use on our glass. Let's see. Oh, I got to filter by free really quickly. And then if I click on this black and white tile. So this is a decently clean looking lighting texture or normal map. So I'll go ahead and grab this one. We're only going to use the one texture from it anyway, so it doesn't matter. So for example, if I go into this one, we'll use this texture here to just add some detail to our glass to make it a little bit more interesting and just to showcase the normal map effect. So I'll just click Save All one more time and then go back to my content browser. All right, once we're back in our content browser, we can really quickly get out some meshes to showcase our material on. So I'll go to add a shape and then a plane, rotate it and scale it just a bit. And then I'll also grab a sphere. Cool, so now we got our shapes to showcase the material on, and now we can create a materials folder. I'll right click in my content browser, click new folder, name it materials. This is just if you don't already have one of these. And then in here, you could create another folder for glass, but I'll just create the material in here. So I'll call it m underscore glass. I'll double click to open this up. All right, now that we're in here, we can change a couple of settings to make this work for the transparent. glass. So blend mode needs to be not opaque. We'll change it to translucent, and then shading model from default lit to thin translucent. Next, we need to go down to lighting mode. As you can see here, we have this error talking about the lighting mode must be surface forward shading. So I'll just change that to surface forward shading. And then we can scroll down a bit more until we find refraction and just change the method here to index of refraction. Now you can see here we have this exposed pin for refraction, and we have just one more error here, and that is that this shading model, this thin translucent model, requires a thin translucent material node. So we can just search for that. If you right click and search, we can find thin translucent material output. And as you can see, it's the same color because it's also an output node. It's a similar type of thing here. So we have our color and whatnot. From here, we can right click and search for a constant 3 vector. You can also hold 3 on your keyboard to get those as well. Now I'll right click and convert this to a parameter, and I'll call this glass tint. I'll double click this and set the default value on the color to be 5, or sorry, 0.5. So that way it's a middle gray color, not fully white or not black. And I'll just plug that into transmittance color. As you can see here, that is now our color, even though we didn't set it here. Actually, let's see if this, yeah, so as you can see, changing the color here still changes it because our opacity is set to 1. So basically when this material is fully opaque, it will use whatever the base color is here. And in that case, we need a dirt color. So I'll just copy and paste this glass tint down here, and I'll just rename this dirt tint. But we can't plug this right in. We need to lerp between both of these colors for this to work correctly. So we need an alpha, and that alpha is going to be from our texture that we got from Fab. So I'll just go back to my content browser, go to Fab, and find that fingerprint texture, and I'll just drag it into the graph. I'll bring this up here so we have a little bit more space. I'll right click it so I can convert it to a parameter in case we want to change it later. And I'll call this dirt mask. And on the left, we can add some things to control the scale. So I'll hold a U and click on my keyboard for a texture coordinate. You can also just search for text coordinate. Then I'll hold M and click for multiply, and S and click for a scalar value. This will be called dirt scale. Default value can be 0.5, and I'll plug this in like that, and this into UVs. From the R channel, I want to grab a subtract node and then add a parameter, and I'll call this dirt bias. This is sort of the amount of the dirt that is on the glass. By default, I'll set it to be 0.5, and then I'll right click and search for cheap contrast. This is just a cool node that allows you to add some contrast to your mask or your texture. And I'll just rename this to be dirt contrast. And this default value can be 0, so it's off by default. And then from here, we want to search for reroute declaration node, and then we'll call this dirt mask. This just allows us to clean up our graph. So anywhere we click and right click and search, we can search for a dirt mask, and it just gets this same information. It's sort of like creating a local variable. And you can even change the color on the first node there, and it will update. So I'll make it more of a dirt color. And I can highlight all of this and click C, and we'll call it dirt mask. And that's looking good. And then we can use our dirt mask here as our alpha. So this will blend between the two colors, and this goes into base color. We also need another lerp and dirt mask for the metallic values. So I'll just copy and paste this down here, and I'll hold 1 and click for 2 constant values here. And the A will be 1, and the second one, or sorry, not the A, but this constant will be 1, and this one will be 0, and then they go in like this. So the A becomes 1, and the B becomes 0. And basically, wherever it's A is going to be our glass. So we want the glass to be fully metallic. So I'll plug this into the metallic output, and the dirt not to be metallic. Epic Games recommends that the glass is always metallic. It makes it look a lot less plasticky. So I'll leave that at 1. And then dirt, obviously it's not metallic. You could technically convert this to a parameter if you had some sort of gold coverage or something that was more metal covering your glass, you could, increase this value here. I'll go ahead and copy and paste to the lerp and the dirt mask once more, and I'll create two scalar parameters. This one will be called roughness glass with the default value of 0.1, and I'll copy and paste that, and this will be roughness dirt. And this value can be 1 by default, so fully rough for the dirt. Can always adjust it later. That's the beauty of parameters. This can go into roughness now, and I'll just drag this back. Now I can copy and paste to this dirt mask node again, and this actually is going to be our opacity output as well. This controls sort of the difference between the two colors, and as you can see, we kind of start to have some smudges on the surface there. From here, we can quickly do the refraction. We're going to skip the normal map just for a moment. So I'll right click and search for a Fresnel node. And if I preview this, you can see that it's wider or brighter on the edge and darker in the center. So we can use this again on a lerp node to blend between two values. So we want the refraction to be more on the edge and not on the glancing angle or the angle that you're directly looking at. So I can unpreview this now, and I'll just create two constant values, and I'll set this first one to be 1, so there's no refraction there, and then this next value will be 1.52. This is the physically accurate value for refraction on glass. It's what Epic Games recommends to use, so we'll just go ahead and use that as well. All right, now we can go ahead and start working on the normal map input. All right, so we're going to add a way to scale the normal map as well as rotate the normal map. So we'll do the scaling first, but I guess first we need to go grab our texture. So I'll go back to my fab folder into Megascan surfaces and get my black and white tile. You might have a different texture that you want to use for adding bump detail onto the glass, but I'll just drag this one in here. I'll right click, convert to parameter, call this normal glass. And from here, we can go to the left and search for texture coordinate. And then I will right click and search for a scale UVs by center. This makes sure that when we scale the texture, it actually scales outward from the center. You could technically do that for the dirt as well, but it doesn't matter as much as more of a geometric texture. It looks much better when it scales from the center and rotates around the center as well. And then we can right click and search for custom rotator. And then we'll plug UVs into UVs and then rotated values into UVs. Now we need two parameters. We need a texture scale one, so I'll hold S and click, and I'll call this normal scale. Default value can be 0.5. Plug that into there, and then I'll copy and paste this down below for normal rotation. And this default value can be 0. We don't want to rotate it by default. We only want to rotate it if we choose to do so later on in the material instance. This will become our rotation angle. Now, technically, this parameter will correctly rotate the texture itself, but not the sort of lighting information that comes along with it. So if I plug this in, we can just quickly view after this loads. So if I go to my normal rotation and rotate it, it will rotate the texture, but it doesn't rotate the way that it's calculating the highlight and shadows of the lighting. So we need to add a way to rotate the normal map. So I'll just Control Z that and unhook that. Drag this back a little bit. And we need to add some math to rotate normal map because it doesn't rotate in the same fashion as normal textures because it has to also calculate the direction of the reflections and things like that. So I found this method from a person named Tech Art Alex on YouTube. He makes more complex math tutorials for Unreal Engine materials and things like that. Definitely recommend checking out Tech Art Alex if you're interested in more of the math that goes behind shaders. But I'm just going to use that method here because it does tend to work really great. So we need to get a couple of math nodes. So I'll just right click and search for cosine. And then I will right click and search for sine, just a regular sine. And then our normal rotation goes into both of those. And then we need to get an add node. So I'll hold A and click, and the B value should be 0.25. Basically, from my understanding, is this is going to do some math on the R channel of our texture to rotate that. And then for the green channel, we need to offset it by 0.25, and that creates a perpendicular angle to the red channel. And the normal maps are all about sort of angles and lighting it to create fake shadows. So that's why we have to do this extra stuff. So I'll copy and paste the cosine and sine. I'll plug the add into those two right there. And then from here, we can right click and search for make float to. We're going to recreate a single value by plugging these two into there. And then I'll do the same thing down here. So I'll copy and paste that. And then from here, we need a dot product node. And we need two of those. So I'll just paste that down here. And then we need to, from the RGB of our texture, search for component mask. And by default, it should just be RNG, which is exactly what we need. It's the ones that we're affecting here. So I'll just drag this down to the A of the dot products, both of them. And then the B is just the previous node from the make float to. And then we just need to combine those two together to create the RNG finally. And this is our correctly rotated RNG outputs from this texture here. So now we just need to re-add the blue vector. And to do that, we can get an append vector node. And then the B goes into the B of the append, very important. And then the A of the append is our previous here. So as you can see, this says RNG. And this is a little diagram showing you what's happening. So this is the R, this is the G. They come together and create RG. And then this creates RG and B. From here, we can drag off and search for flatten normal. And then we can create another parameter. I'll just copy and paste this normal rotation node. And this will be called normal flatten. By default, it'll be 0, so no flatness, so we'll get the full strength of the normal map. And a value of 1 would be fully flattened, so you wouldn't see any effect. Now we can go ahead and select everything here. Click C, we'll call this normal map. And from the result, we can finally drag this into normal. I guess if I dragged all this up here, we could create a little bit more of an organized graph really quickly. Awesome. Looks much better once I get these up here. Cool, so now we're good actually to save and go back to our level. I can go back to my content browser, find my material folder, and I'll right click on my mGlass and create material instance. I'll call this mi_glass_1. And I'll just drag it onto both of these. Really quickly, I just want to double check, make sure that my screen percentage is at 100. That way we don't get any extra artifacts. And from here, we can double click our material instance to open it up. And just kind of have it on the side here. We want to turn on all the parameters to make some adjustments. From here, I want to click F11 just to go into full screen. Sometimes it lags for a second. And then here we have our dirt bias and so forth. So if I lower the bias, you can see it brings more and more dirt until it's fully covered. And then the opposite way is going to take it away. The contrast is quite what it says. It literally is going to add contrast to the map and basically take away those in-between gradient values that, in my opinion, do look kind of nice. So we don't want to add too much contrast. I like to add maybe 0.25 and then adjust the bias from there so it's not too much. I don't want too much dirt on my mesh here, but you can obviously experiment with this and add as much as you want, as well as change the color of the dirt. I'll go ahead and make sure that it's still on the gray. And the dirt scale is going to control the tiling of the dirt. So if you lower this value, it makes it really big. And if you raise it, it tiles it more often, which is kind of nice. So if you wanted like really slight smudge marks, what I would do is probably increase the scale so it's they're tiled more tightly and they'll be a little bit more realistic. And then lower the contrast and then the bias, increase that. Yeah, so now you get those really slight smudge marks kind of all over that react to the light a little bit differently. So yeah, you can mess around with this until you get the desired result, but just know that you can mess around with these contrast values until you get more of a subtle smudge mark look or an actual full-on like dirt coverage look. That's how you would mess with those. The normal flatten is going to flatten it if it's a value of 1. So as you can see, the normal map went away. There it is back. And then 0.5 is going to be sort of halfway flattened, but maybe 0.8 or 0.9 makes it real subtle, makes it look like it's not that deep for those crevices. I'll do a value of 0.5. I think it looks pretty good. And then the scale, I'll skip rotation for now. The scale is going to control, obviously, the scale. The higher the value, the small or the more like zoomed in it looks. And then the smaller the value, the more it tiles. And then the normal rotation is going to rotate the normal map, and it's going to be correctly rotated because we did that extra steps with the math. So now it correctly reacts to the light, depending on the angle, and it's looking pretty good. I'll set my normal rotation to 0.25. I do happen to know that 0.25 is going to rotate it 90 degrees. I believe this is in radians, so a value of 0.125 is 45 degrees. So can give you a good look if you have a nice symmetrical texture, kind of creating an angled geometric look. Looks pretty nice. And then, of course, 0.25 is 90 degrees. 0.5 and 0 are basically no change. So I'll just leave mine at 0.25 so we get this vertical look. Scale I'll set to 0.25. And the roughness dirt is going to control the shininess of the dirt. And you can bring this past 1 if you want to really force the dirt to be rougher looking, as you can see, or you can lower it if you want it to be more in line with the glass. I just leave it at 1. I think it's simple that way. And then the roughness for the glass, of course, can be changed. 0 is going to be even more reflective, and you can see the smudges a lot clearer now because there's more of a difference between the roughnesses. But I still think 0.1 or maybe even 0.05 is a little bit nicer. And yeah, so we have our glass tint. You can tint the glass any color that you want. Get some really cool results. That. And if you lower the value of the color down to fully black, it will basically look totally opaque. And then full color will be more transparent. Yeah, so this is a more realistic way, I guess, to handle colored glass. The darker the color, technically, the more opaque it looks. And I do tend to think that that is pretty accurate. So this is just a more realistic approach to coloring your glass and messing with the opacity. And then on the sphere here, we can probably better visualize the refraction. So if I turn the brightness up, you can see here that this ramp here starts to bend with the surface of the sphere. So that's looking pretty good. Nice refraction there. And technically you could convert that refraction parameter, this here, to a parameter if you really wanted to emphasize how much refraction, but I do recommend leaving it at the realistic value of 1.2 or 1.52. One thing to note is that the backside of this glass will be non-existent because we didn't set this to two-sided. Anytime that you set a material to be two-sided, it is going to add a little bit more performance cost, but it will technically become two-sided. It'll take a sec to load, but there you go. Now it's two-sided, but you will get some weird results on some meshes. So as you can see here on the sphere, this top notch here is not correct, but as soon as I turn off two-sided, it looks correct. So what I recommend doing is going back to your material folder and creating a material instance of your first instance. Once you have this looking good and how you want it to, you can create a material instance of this. And I'll call this _1_2 sided. So now we have an instance of a master material. If you want to check out my video on material hierarchy, I definitely recommend it. It's a really nice video on how to set up your materials to become more organized and scalable. And this is an example of that here. So what I'll do is open up both of these material instances. So as you can see, I have MI Glass 1. This is the first one that I made. And I'm going to make sure two-sided is checked off. This is the one that I want to use on things like um, maybe a sphere or a sculpture. And then on the MI glass one two-sided for the plane, I do need it to be two-sided. So I'll leave all of these checked off so they don't make any changes. And then I'll go down all the way to the property overrides here and check on two-sided. Now if I set my two-sided version to be on the left, the back of it should be glass, but my sphere still looks correct because the sphere is still using the first one that's not two-sided. But what's nice is if I go into my sphere material here and, for example, just change the color from blue to red and click OK, it will update the instance of this instance, which is the one that's two-sided that we just created from this instance. So it's a pretty handy trick in case you need one that's two-sided and one that's not. All right, another thing I want to show is just the reflection quality of this. So if I go over to the glass, you can see that we do have a nice reflection at certain angles. So if I'm like at this angle here, you can see the full character, but as I rotate, it kind of falls apart. And one way to get around this is if you have an NVIDIA card, you can enable hardware ray tracing, and we can just go ahead and do that real quick. I'll go to Edit, Project Settings, and search for ray tracing, and check Support Hardware Ray Tracing. Click this, and then will ask you to restart. Just go ahead and do that. It'll ask you to save anything, and then I'll meet you back here after that. Once we've loaded back up and the shaders have recompiled, I want to go back to the project settings really quickly for a couple more settings that don't require a full restart. And that's going to be the ray lighting mode. So we can change this from surface cache to hit lighting for reflections. We can enable high quality translucency reflections and also change the software ray tracing mode. This is for if you don't have the ray trace available. This will look better with the detail tracing. And I may actually be wrong on that. You might have to actually have this enabled for this. I'm not quite sure, but nonetheless, these are some good settings to have for better reflections. I can go back, and then I'll just go to my post-process volume really quickly and turn on Lumen there. It should be on by default, but I just like to check to make sure. And then we can also increase some settings here. So we got the final gather quality. I'll just set this to 2 so it's maxed out. And go down to reflections, and then lumen quality, set that to be 3. That should be maxed out. And this is already on. If it's not already on, just click this on the left and make sure that's on. For the high quality translucency reflections, I think it should be on because we did it in the project settings. And then that should be good. So now the reflections are a little bit nicer, and let's test with our character. Just hit play, and then I'll go full screen. So as you can see, now we have the actually full reflection of our character and not just a little cutout, no matter of the angle that we look at. So that's looking pretty awesome. Obviously, it's going to be a little bit more expensive, but everything comes at a cost, including perfectly ray traced reflections. So, all right, guys, that's going to do it for this video on how to create an updated thin transparent glass material that has realistic effects like smudges and a normal map for adding detail to the surface, as well as how to enable some ray traced reflections and improve lumen quality altogether. If you guys enjoyed this video or learned anything new at all, it'd mean a lot to us if you left a like on the video and subscribe to our channel. And definitely go check out Skyblocker on Steam. We promise you won't regret it. This has been Vylocity with Pitchfork Academy, and I'll see you in the next one.